We'll wait for more 5 to 10 minutes. Let others to join. Then we can start the session. Fine. We'll start today's session. Good evening, everyone. In continuation to the previous class, let me see. In continuation to the previous class, so today's session we discuss force concept. Force, we know the basic definition of the force. So force is nothing but in a simple words, we say it's a pull or a push to another body. Force is the action exerted by one body to another body. In simple words, we can say it is a force. When we say the word force, there are three properties of the force. They are magnitude, direction, and point of application. Magnitude, direction, and point of application. These are the three properties of the force. We know that there are different types of force like compression force, tension force, shear force. And we know the definition of a force. But what is the magnitude of the force? Few of us don't know exactly what is the magnitude of the force. It is just the weight of the force. Magnitude of the force means with what magnitude. For example, if I say this is a force, isn't it? Or else, for example, this is a beam. This is a force. Load or a force acting on a beam. Now, if I say this is a force, every force has magnitude, direction, and point of application. For this force, what is the magnitude? Let us say 10 kilonewton load is acting on this beam. It means the magnitude is 10 kilonewton. If I say this is a 5 kilonewton, then the magnitude of this force is 5. So as I have told you, there are three properties of force. One is the magnitude, direction, and point of application. Magnitude, this is the magnitude. And direction, which direction it is going downward. And this is right side, left side, and upward. So there are four directions. Obviously, force can go in four directions. And next is the point of application. It means where this force is going to act. If you see on this beam, the point of application means this one. Where is the point of applying this force? That is called point of application. These are the three properties of a force: magnitude, direction, and point of application. So here, if you see this figure for understanding, this is the point where it is starting and it is going in this direction. And this here is a pointing starting of the point and it's going in this direction. And the back side of that direction is called line of action. For this force, the magnitude is 100 kilonewton. 100 kilonewton magnitude. And it is going in this direction. The units of force is Newton and kilonewton. Magnitude is the amount or size of the force. As I mentioned, it's a 50 or 100 or 1 kilonewton, whatever it is. And the direction is the side arrow. At which side the arrow is going on. That is called direction. And point of application, where is the point starting? Now these are the directions: upward, downward, left, right, towards the left, to upward the right, and downward to the left, downward to the right. These are the four directions. So force can go, this is upward. This is right side. This is downside. And this is left side. And if you see, if a force is coming in this direction, then it is upward to the left. And if the force is going in this direction, upward to the right. And downward to the left downward to the right. Is it clear? So these are the directions. Now, you may be asked to determine the resultant of force. You know the force. You have to calculate the resultant of that force. To calculate the resultant of force, you should know the horizontal and vertical forces. We are having a few formulas. This is called the resultant. Okay. Next. Fine. Resultant will come later. So to calculate the force, horizontal force and vertical force. Force might be horizontal or vertical or inclined or vertical or horizontal. Any type of force might be there. So depending on the direction of the force, we have to calculate the force. And based on the horizontal and vertical force, we have to calculate the resultant. So for this, I'll try to make it more simple. If there is a horizontal force, cos theta. If there is a vertical force, sin theta. Just remember this. If there is a horizontal force, cos theta. If there's a vertical force, sin theta. Now, the formula is P is equal to horizontal force plus vertical force under root of square. So anyway, we'll see some example problems to make you understand. If you see this beam, simply supported beam, how many forces are acting? 3 forces are acting. 2 forces are, one force is downward and one force is upward and one force is upward right. Isn't it? Upward, downward and upward right. So now we have to calculate the force. Determine the properties or characteristics of force. The first one. You have to determine these 3 for this given figure. The properties of characteristics of force and okay. This is for T, P, W. This is T, P and W. So for these 3 forces, you have to calculate the characteristics or the properties. So what does it mean? For this given beam, 1 meter from the end of 1 meter, you are having a force. And again for 4 meters, you are having a downward force. And after 4 meters, there is a upward right force. So these are the given dimensions of a beam. Now you have to calculate the properties of these 3 points. So the first one, at point T, magnitude of force is given how much? 2 newtons. And what is the direction? Angle is given 60. Upward to the right. So what is asking here? To determine the properties or the characteristics. So here you are not going to determine the force or the resultant. Just you have to point the properties or the characteristics. It means you have to say on which direction it is moving on. Like in the previous slide we studied upward right side, downward and left side, upward right. Those directions you have to mention here. And for the second point, what is the magnitude? 5. And what is the angle? 90, because it is exactly coming down. So it is 90 degrees. And what is the direction? So for which it's a P, right? This one. This is for P. Since it is straight upward, 90 degrees. And what is the direction? Upward. And point of application from 1 meter to the end. And coming to the force W. The direction is downward and 90 degrees, and the magnitude is given 5 newtons. So in case if it is asked to determine the properties or characteristics, you have to mention the following, like what is the magnitude of that force, what is the direction, and what is the point of application. These are the three properties, isn't it? What are the properties of a force? Magnitude, direction, and point of application. Magnitude means whatever the load or force acting by the force, and direction, on which direction. We are having total 8 directions: upward, downward, left, right, upward left, downward right. So these are the directions of force, and point of application, from which point it is starting or acting. I hope you are aware of this. Right side always positive, left side always negative. Upward is always positive, downward always negative. Now, if you see this picture, in this figure, it's asking to determine sigma fx and sigma fy and resultant. Sigma fx means sum of forces in the x direction. Sigma fy means sum of force in y direction. Fx means in the x direction. F means force. This is summation or sigma. It's up to you. You can terminology. You can use any terminology. Means total. Total of Fx. Total of force in x direction. And Fy. Total of forces in y direction. And resultant. So here you have to determine these three questions. So the x and y components of force T, x and y components of force P and Q. There are three forces acting here. In the previous figure, the forces are acting downward or upward, which is easy for us to understand. It's 90 degrees or the degree is given for us. But for this question, the forces are given one horizontal and both inclined. We can say upward left, upward right, isn't it? So these are the three forces given. And the angle for force T is 45 degrees. The angle for force P is 60 degrees. And for angle for force Q is 90 degrees, since it is horizontal or 0. It is 90 degrees means like this, it is 0 or 360 degrees. Now, what I have told you, if it is a horizontal, you have to remember that cos theta. If it is vertical, you have to remember it as a sin theta. What is asked in the question? To determine the summation of Fx, means sum of horizontal forces, and Fy, sum of vertical forces. So how many horizontal forces are there here? And how many vertical forces are there? We don't have exactly vertical, but both are upward, right and left. So for the first one, T. So cos theta x is equal to T by, let me try to give you more simple way. Okay, let me write it here on board. So for this, the first thing you should remember, horizontal means cos theta and vertical means sin theta. Now, here in the question, it is clearly asked to determine X and Y components of force T. X and Y. It means for each force, you have to calculate in the X direction and Y direction. So for the X direction, what is the formula? Cos theta. For the Y direction, sin theta. Now, for the X direction, for this given T force, formula is P cos theta. Let us say Px. The force is denoted by T. We are doing for the force T and in the X direction. So the formula is P cos theta. What is P is given? P means the force. How much it is given? What is theta? 45. So if you substitute, how much you will get? How much it is there? 70 point. Is it clear? Now, this is X direction. It is clearly asked in the question to determine X and Y component. So this is for the X component. What is for the Y component? P sin theta. What is P? 100 sin 45 degrees. Same. So this is for the force T. Next, for which force? P. For P. Px is equal to P cos theta. What is the magnitude? What is the angle? Similarly for P in y component, y direction. P sin theta. Is it clear? Now, what is the next force? Q. Q in X direction. What is Q? 20. What is theta? Is it clear? So here in this question is clearly asked to determine the X and Y component. Therefore, for each force, you have to calculate force in X direction and force in Y direction. Force in X direction means cos theta, Y direction means sin theta. So for each force, you are calculating X direction and Y direction. For the Q force, it is acting horizontal force. Therefore, there is no angle. What is this quadrant? Do you remember this? In mathematics. First quadrant, second quadrant, third and fourth. So this quadrant, what is the angle in this quadrant? 90. This quadrant? Isn't it? Yes. In this quadrant, everything is positive. Isn't it? Here? Okay. I don't want to go mathematics. So here, relating to our topic, first quadrant, second quadrant, third quadrant, fourth quadrant. Now, this, if any force is acting here on this line, it is exactly 90 degrees. This is 90 degrees. And if any force is acting exactly at center, this is 45 degrees. Isn't it? So these are the basic things you have to remember. No need to be thorough with the mathematics for this. If any force is acting exactly on line, that means it is 90 degrees. If any force is acting exactly center in the first quadrant, then it is 45 degrees. Is it clear? And if any force is acting on this line, it will be 0 because that is the datum line. So this is the simple thing that you have to remember. Otherwise, you may get doubt how much value, how much angle to be taken. Is it clear? How to calculate X and Y component force in X for each point P, T and Q. This it's the force formula P cos theta. Force. You can use any terminology. You can use T, you can use P, you can use F. P is nothing but representing force. Sorry? Like X, I didn't get you. No, see, generally in structural mechanics fun, whenever we solve any problem, let us say this is a beam. This is a load acting on this beam. You understand this, right? Right? So how we denote this? Yes. We denote this as a P. That means this much load or this much force is acting on this. So I don't want to give you different terminologies because we are going to use P as load or a force in all solving problems. Now, here in this question, it is asked to determine resultant also. We calculated only the forces, horizontal force and vertical force for each point. What is the formula to calculate the resultant? Under root of Px plus Py. I think square is there or not, I'll check. Under root of Px plus Py. So what is under root of Px? Summation of Px. Summation of Px means X direction, this one, and this one. All the values in X direction is summation of Px or Fx. Now, summation of Py or Fy is a force in Y direction. This one and whatever the answer you get for this one and whatever answer you get here. All the X component forces should be added. All the Y component forces should be added and under root you will get the resultant. Sigma Fx is equal to 70.5 minus 5 minus 20. Here you got 70 and here you got minus 5 and here you got minus 20. And similarly for Fy direction 70.7 plus 8.7 and I think for this is 0. So you have to add all the forces in X direction and you have to add all the forces in Y direction. Then you have to square root to get the resultant. Is it clear? Similarly, in continuation to this problem, so in the previous slide, in the previous problem, what we have discussed, to determine the characteristics or properties of a force. What are the properties of force? Magnitude, direction, and point of application. These are the three properties of a force. And now we discussed how to determine the resultant. What is the formula of resultant? Under root of summation of forces in X direction plus summation of forces in Y direction. Then you get the resultant. How you calculate forces in X direction? P cos theta. How you calculate forces in Y direction? P sin theta. Is it clear? Now, the next step is to determine moment. So after calculating the resultant, so next step is to determine the moment. Moment of a force. every force having movement. So how to determine that movement? What is the formula? Actually, what is mean by movement? Movement of a force is defined as the measure of the ability of a force to produce turning or twisting about an axis. It means, for example, this is a support. This is a support here, and this is a beam, or this is a, let's say, material or a beam. And one force is acting here, another force is acting here. If you see here, it is twisting, it is turning. So there will be some movement. So that movement of force is determined by the load into distance. Whatever the force is acting and whatever the distance it is from the end, that is called movement. For example, if you see in this question, a simply supported beam carrying a downward left force of 100 kilonewton. So regarding your question, why P? So here also P is denoted. So P is equal to 100 kilonewton and angle is given 60. For this question, if it is asked to determine properties or the characteristics of forces, so what is the answer? For this given figure, if it is asked to determine the properties of force, what answer you give? Yes. I just want only properties. Magnitude, how much? Okay, next. What are the properties of force? Yes, so first is magnitude. How much? Next. Which direction? Downward left. How much angle? So that is direction. And next, point of application. 2 meters from left end or point A. 2 meters from point A or 3 meters from point C. So that is the point of application. So this is how you have to write the properties of a force if it is asked for any given figure. Is it clear? So for this, to determine movement, first solve the values of Px and Py. So first, what is given in the question? For the simple beam given in the figure, solve the following. Movement of force P about A from here to here, from this side. Considering from this side, calculate the moment. Next, movement of force P about C. Next, you have to consider the from this end and you have to calculate the moment. And calculate the moment of force about point B. From this point, calculate the moment. So from each point, you have to calculate the moment. Wherever the point starts, the formula is same. The formula is same. Load into distance. Remember this. Okay. It is easy for you to understand. Load into distance. Now, so first, to determine the moment, we have to solve Px and Py. So Px is equal to, as you know, x means cos theta. Py means sin theta. X direction cos theta, y direction sin theta. So Px, P cos theta. What is P given? 100. And P sin theta. P sin theta. So you got Px and Py. After getting this Px and Py, you have to calculate movement from point A, from point C, and from point B. From 3 points, you have to calculate the movement as per the given in question. So first we see how to calculate the moment of force P about A, means from this direction. Movement at A, whatever the load in the x direction and this load from the y direction, the total sum of the loads, MA plus M by X direction and Y direction. The total load is 173.2 kilonewton meter or Newton per meter, Newton meter. Similarly, from the point C, X minus Y, if you see X minus Y, if you see here, at point A, 86.6 into 2. Here 86.6 into 3. I have given one formula to you. Movement is equal to load into distance. You remember it. Now, how to apply that formula? Movement at A from here. From where we have to calculate, for which point we have to calculate the moment? For this point, isn't it? From this point to this point, we have to calculate movement. So what is the formula we have? Load into distance. What is the load here? How much we have? 50. Isn't it? X direction, how much? 50. So it is how much? Minus 50 plus you are going in the clockwise direction, right side. What is the load here? In the y direction, how much? No, 86. Y direction, how much? 86. But how much distance it is? 2 meters. So, as I have told you, load into distance. You have to remember this formula, load into distance. What is the load? Y direction, 86.6. Multiply with, what is the distance? 2. If you see, for the second case, about the point C. For this case, you have to come from this side. You have to come from the left hand side or anti-clock. So here, what is this distance? 3. If you are coming from point A, the distance is 2 meters. But if you are coming from point C, the distance is 3 meters. So here, the distance will be 3 meters. Is it clear? So maybe first and second numericals you may get confused, but if you keep on doing this type of example problems, then you will understand. You will become familiar. We'll do some examples. I'll try to make you clear with these type of questions. Now, in the third case, movement of force about point B. Where is from here? It is asking to determine the movement. From this point to this point, is there any distance? No. From point A, you are having 2 meters. From point C, you are having 3 meters. From point B, how much you have? 0. 0 into something? 0. You got it? From point A, you have to consider whatever the distance you have until this point. From point C, you have to consider this distance until this point. From point B also, you have to consider distance until this point from this point. There is no distance, therefore it is 0 at the point B. Similarly, this you will get confused. Not required now. Okay, let us see this. For this given simple beam, you have to calculate moment of force P about A. Look at the question clearly. This is something which we have done previous problem. Similar to the previous problem. Moment of force P for this force, you have to calculate movement from point A, from point C, from point D. Similarly, you have to calculate moment of force F from point D, from point A, and from point C. Isn't it? What is this answer will come? The last one? Here. Now give me the first answer. So at least give me the procedure. What is the first step to do? Px and Py of P and F. You have to calculate. If you are doing only for this, first you have to do for this. So you have to calculate Px, Py. What is the formula to determine for Px? P cos theta. What is P? 4. Cos theta. What is theta? 90. So you get Px. What is the formula for Py? Means how much? 4 sin 90. You will get some value. From this point, for this point you will get some value. Now, what is the first says? First question asked you, moment of force P about A. Means from this direction, from this point. Px plus Py, let us say 10. Just imagine. Or else Px is equal to 2 and Py is equal to 8. For your example, because I don't think this is a solved problem. No. This is actually given to you for a task. So let us assume that Px is 2, Py is equal to 8. Clear? So what is asking here? Moment. A, B. So this is the given question and these are the required. First, what is required? Moment of P. Isn't it? So for this, what is the first we need to calculate? Forces Px and Py. What is the Px? What is the formula? What is P? What is the answer? Sorry? 0. Py? How much? Now, movement of P about A. So, from this point to this point, what is Px? 0. Px is equal to here, this is 0. Plus how much? Py. And what is the distance? How much you get? Is it clear? Next, movement of P about C. Isn't it? Where is C? Here. So what is Px? 0 minus how much? 4. What is the distance? 2 meters. Isn't it? Next, D. From point D, please tell me how much? Huh? Is it clear? Is it clear? Everyone? Can you go again? Which one? D you find? From this point to this point. We have to calculate for this point. For D, Px, since it is a left side, minus Py. And what is the distance from here to here? Now, if you see the second one, C, same logic. But what is from C only, you have to calculate. How much? Is it clear? Now, for movement of force F, 60 degrees is given, right? Now, Fx Px is equal to how much? P cos theta. What is P? Cos theta how much? How much? How much? So we calculated Px and Py. Now what you have to calculate? Movement from point D. Movement of force F from point D. How much? Please tell me. How much? From point D. Yes. How much? Give me how much, like. How much? Length how much? Sorry. Sorry. I was in still here. So how much it is? X 5. Is it clear? Px, Py, and the distance is 3 meters. Minus. Next, from point A, give me the value for point A. How much? No, give me that total. Not like that. Complete equation. 5 plus 8.6, how much? How much? Is it clear? All of you, take 2 to 3 minutes time to check it and ask me if you have any questions. If you do not understand how these steps has come, you please ask me. I will explain you. Clear? Yes. I don't know. You gave the answer. 20 point. See, you are giving me answers. I'm just putting the answer here. Okay. Is it clear? Any questions? Any doubts? Any question? Because no, for the value you have to write. Whatever the value, final value you get, for that you have to write. Okay. So the next topic, centroid. In the previous lab, our first lab last week, we conducted our first experiment, center of gravity or centroid. You're having an information like what is a centroid or what is the center of gravity of any material. Either it is a regular or irregular shape. Now we are going to solve few example problems of centroid for different material or different shapes. Before that, we'll see what are the different type of supports, what are different type of beams, and what are different type of loads acting on a beam. So here you can see different type of supports. This is called hinge support or pin support. There are three type of supports. First thing you should know that there are three types of supports. First one is hinge or pin. Both are same. Second one is fixed. And third one is roller. For example, if this is a beam, if this beam is fixed one end or both ends, this support is called fixed support. Sometimes the beam is just supported on, just supported. That is called support, simply support or hinge or pin. And sometimes a beam is resting on a roller. That is called roller support. So there are three types of supports: pin or hinge, fixed and roller. These are the three supports. This is how a pin or hinge support, and this is how roller support, and this is the fixed support. You can see. These are the fixed supports. Fixed means it will not come back or it will not move. It is fixed. This is roller support. You can see on the bridges. Yes. And this is a pin or hinge support. So these are the three types of supports in general we use for different type of constructions. Is it clear? Three supports. Okay. So before going to discuss centroid, we discuss this. I think if we manage time, we can. If you have time, we discuss centroid. Otherwise, we'll stop after discussing this topic because it will take some time. Now, let us take this is a beam. So what type of beam it is? In the last class, I have told you different type of beams. How many types of beam we have? How many types of beam? How many? 5 types. If you don't remember, please write down in your book. Cantilever beam. Cantilever beam, one side fixed, other side free. Simply supported beam, both sides are supported. Fixed beam, both sides fixed. Continuous beam, when there are more than 2 supports. When there are more than 2 supports. Overhanging beam, sides are hanging without support. So these are the 5 different types of beam: cantilever beam, simply supported beam, fixed beam, continuous beam, and overhanging beam. Sometimes there will be another type of beam in cantilever. Cantilever beam means one side fixed, other side free. There is no support. But in case if there is a support, then it is called propped cantilever. Generally, cantilever beam means one side fixed, other side free. In some cases, if there is a support, one side fixed, other side having support, then it is called propped cantilever. If there is no support, then it is called cantilever. Simply supported beam, 2 supports. Fixed beam, 2 sides are fixed. Continuous, more than 2 supports. Overhanging beam, the sides are hanging without any support. Is it clear? Different type of beams. Now, what type of beam it is? Cantilever beam. What is this? Force or load acting at end, free end. Load is acting on a free end of cantilever beam. So there is a principle of superposition theorem. In your mathematics, you are having different theorems, right? To derive a formula, we have to derive some theorem. Similarly, here we no need to derive any theorems. From this superposition principle is stated that P is equal to P1 plus P2. P is the total load. P is the total load. So here, this divided into this plus this. So principle of superposition theorem says that whatever this is the total load P. A cantilever beam is acting a cantilever beam where a point load is acting at free end. So this load, whatever is that P, can we say P1 plus P2? Isn't it? So in this case, what happens? This is one P1, this is P2. So it's nothing but it is making simplified. So that is called superposition theorem. Superposition theorem. Now I will give some formulas. You please note it down. Stress. These three formulas, just note it. Stress, load by area. I think you have studied in industrial civil engineering. Yes. Stress, load by area. Strain, change in length divided by original length. Young's modulus, stress by strain. Okay. Now, the reason of giving these three formulas because I want you to understand of Hooke's law. Hooke's law also you have studied in Introduction to Civil Engineering. What is the definition of Hooke's law? Stress is directly proportional to the strain. Stress is directly proportional to the strain is called Hooke's law. It means, and that is what we are going to do in today's lab. In today's lab, we are going to do tensile test. All of you please listen because some of you are having lab today and others tomorrow. So for tomorrow also you need this explanation, right? So I will explain the experiment how to do today and tomorrow. Now the experiment which we are going to do today is tensile test. In that experiment, you are going to determine strain, Young's modulus. You are going to determine stress, you are going to determine strain, you are going to determine Young's modulus and tensile strength. After all, I have asked you what is Hooke's law because Hooke's law says that stress is directly proportional to the strain. To understand this point, you should be aware of three: elasticity, plasticity, and rigidity. Do you remember the definitions of elasticity? What do you mean by elasticity? Yes, you're right. Who? when load is applied on a beam, it undergoes deformation or bending. When it removed, it comes into the original position. That is called elasticity. When a load applied on a beam and it goes to deformation, but when you remove the load, it will not come into the original position. It will be like this only. That is called plasticity. And other one is when you apply load, it will not go into the deformation, but if you still increasing the load, it will give or it will break directly. That is called rigidity. Elasticity, you can give example as eraser or rubber. Plasticity, plastic water bottle, and rigidity, any hard substance. So these are the three states: elasticity, plasticity, rigidity. Now, as I have mentioned, Hooke's law. Hooke's law means stress is directly proportional to the strain within the proportionality limit or elastic limit. Elastic limit means when you apply load, it goes in deformation. When you remove the load, it comes into the original position. So please remember this point. Now, when you apply some load to any material, let us say steel or any material, it undergoes some deformation. But if you remove it, comes into the original position if it is in the elastic limit. Otherwise, if it is crossing the elastic limit, then the next limit is called plastic limit, where it will not come into the original position. See, this is what you have to draw today's experiment. So here, this is called stress strain curve of a mild steel. Stress strain curve. This is the stress and this is the strain. So when this is called elastic limit. After crossing this elastic limit, then this is called upper yield and this is called lower yield. This distance is called yield stress. Yield stress means about to get failed. If I say I'm applying load, for example, I'm applying load on this material. So when this material is about to break, that is called yield stress. That is called yield point. So when I'm applying load and I know that I come to know that it is about to break, that is called yield point. And after the yield point, if I just give one, like if I do apply force once again little bit, it will fail, it will break. That is called breaking point. That is called breaking point. The point where it's a maximum that can be taken by this material. The maximum force that can be taken by this material is called ultimate. Elastic means I'm applying load, but if I remove, it will come to the original position. There is no problem with this. Still, it regains its own property. It's before properties. So there is no problem to this material until this material is in elastic limit or elastic state. But once as I'm applying load, but I am not removing it. I'm still continuing applying load, and it is crossed elastic limit. It enter into the plastic limit. Once it enters into the plastic limit, even if I remove the load, it will not come into the forcing position because it is in the plastic limit. Is it clear? So when it is in the plastic limit, it bends like what it is based on the load. When it is in plastic limit, even if I am applying load, then it goes to the yield point. Once it enters into the yield point, the next step is going to break. It is the I don't know whether I have given this example in the last class or not. A person who is running. I don't think I have given you this example. I'm trying to relate this example to make you understand this stress strain curve. For example, a person is running. Initially, when he starts run, he is fit, isn't it? So that is, he can run up to some, let us say 100 meters or 50 meters. And if he stop, he will be fit. He don't get that breathlessness. When we run, what we get? Breathlessness. You know the word, right? Breathlessness. Is what do you call the word? Arabic. When you run or if you climb the stairs, three stories or 4 stories, there will be some difference or not? How would it be? Yes, that's called breathlessness, something. So the person after running 50 meters and if he stop, he is fit. That means he is still in elastic limit. He regained his energy. Are you able to understand this point? So after 50 meters, again if he is still running continuously, he didn't stop. He started there and is running up to the 100 meters. It means which is out of his range. Once he reached the 100 meters, then he is in the plastic limit. Even if he stop there, he will get that. He's getting the breathlessness. And if he stop at 100 meters and if he sit there, he'll get the breathlessness, but he will be tired. But if that person didn't stop and if he's still moving continuously from 0 to 200 meters, after 100 meters itself, he started getting breathlessness. He is running towards 200 meters. At 200 meters, the yield point. That means he's about to fall down. Because generally, when we run fast, then definitely we'll fall down at one point. That is called yield point. The moment when you are about to fall is yield point. You know that if I step one more, then I will fall down. That is called yield point. And if you step one more, then definitely you will fall down. That is called breaking point. Is it clear? If there is any load acting on a beam or any material, if you remove it, it will come into the original position only until it is in the elastic limits. If it enters into the plastic zone, that means if you keep on applying the load, it enters into the plastic limit and will not regain back. And if you still apply the load, it goes to the yield point, that is the ultimate stress. And after still you applying the load, the specimen will break. So Hooke's law states that Hooke's law means the stress is directly proportional to the strain within the elastic limit. That is the definition of Hooke's law. The stress is directly proportional to the strain within the elastic limit. It means whatever the stress you give, the same amount of strain. It means the person is running, right? Running, let us say this is a stress. He is running with some force. Whatever the force using by him, accordingly he will get that breathlessness. If you walk slow, you will not get that immediately, isn't it? If he run fast, he will get very fast. If he runs slow, he will get very slow. So stress is directly proportional to the strain within the elastic limit is called Hooke's law. So that is applicable in this today's experiment that is called tensile test. In this experiment, when we are applying some load, some stress, the strain is also similar. If you are giving very little stress, little strain, until elastic limit. But once it crosses the elastic limit and enters into the plastic limit, even if you give very little stress, the strain will be high. The same example what I have given. After you cross your elastic limit, or once you start the breathlessness, even if you run very little distance, you will get more strain, isn't it? Try to imagine and relate with this example. So, after elastic limit, even if you give little stress, the strain will be more. The strain will be high. And up to the maximum load that can be taken by this material. And after that point, it is a breaking point. And that point is called yield point. The yield point is the final point. After that, the material, if you apply load, it will break. So in today's experiment, what you are going to do is, there is a specimen, because I don't think I can explain it down. So I'm explaining here in the class itself. So try to listen carefully and do the experiment. So there is a specimen, steel specimen, cast iron, and aluminium. Different types of specimens we have. We are going to use steel specimen. I have given this formulas. Stress is equal to load by area, strain is equal to change in length by original length, and Young's modulus is equal to stress by strain. Because those formulas are going to be useful in today's experiment. If you are not aware of those formulas, then it is difficult for you to write in the report or in the exam. So, let us say this is a specimen. For this specimen, you have to calculate dimensions. You have to calculate length, breadth, and depth. Using vernier calipers, you have to find length of the specimen, breadth of the specimen, and depth of the specimen. After calculating these three dimensions, using breadth and depth, you have to calculate area. You have to calculate area. So, to calculate stress, the formula is load by area. So, this area you will get from B and D, breadth and depth. And this load, you will get when you are applying load. Say, I will explain you at the equipment, but before that, if I give you some information, when I explain on the equipment, then it is easy for you to understand. Okay. So, load, you will get it when you are applying load. When you are applying load, on the dial gauge, you can see how much load is applying. So, based on that, this value, you get this load value. Once you get this load value, load by area gives you stress. And similarly, when you keep on adding the load, when the load is applying on the specimen, then this specimen is fixed, this end and this end. Both ends are fixed. So what happens? Just imagine this side is fixed and this side is fixed. So from this side, it is pulling. This side, it is pulling. What happens to the specimen? Are you able to get my point? This is a specimen, it's fixed both ends. And this end is pulling. So what happens to this specimen? It will break. It will break in the middle, isn't it? It will try to resist the load which is coming. But till what time? Until it is in the elastic limit, it can resist. If I stop giving load, then this specimen is okay. If I apply load continuously, then this specimen enters into the elastic zone and plastic zone and then yield point. So at each point, you have to note down the value. At each point, you have to note down the value of change in length. And already you have calculated the original length. So whatever the change in length that you observe at each point, let us say 0.1 is the changing length at some point. So the strain at that point, 0.1 divided by the original length. You will get strain at that point. And Young's modulus, stress by strain. There are around 10 to 15 points. So for at each point, you have to calculate stress. Strain, Young's modulus. Okay? At each point, to calculate stress, you should calculate load. Because area, you'll get it from the dimensions. But you have to calculate load for at each area. That load you will get from the dial gauge. All of you please try to listen here. Don't think that after going to the lab again, I'll explain. Even I explain you one time, it is not easy for you to understand. That's the reason I'm trying to explain within the class. So at each point you have to calculate stress, you have to calculate strain, you have to calculate Young's modulus. Until the specimen break. Okay? Fine.